Ladies and gentlemen, good evening. Tonight we're going to look at how we can Aes256 encrypt something. There are, they say that standards are good, that's why there are a lot of them, and that's exactly the same what actually is applied to the encryption. There are so many ways to encrypt your data actually, but one of the more popular one is Aes encryption. So let's get right into it. I have created an Aes encryption class right here. And what does this do? Is it takes a salt. A salt is kind of like something that makes it, it's used to make it more random. So that is the salt, and then you have a key. That is the key that is actually made to encrypt the data itself. So that means that So the key is the one that you need to be able to decrypt the data afterwards. So you use that key. That is, without that key, no one can actually see the data. That is the whole point of Aes256 encryption. And remember that encryption and encoding is definitely not the same thing. Encoding, like we also do right here, we actually encode it to base 64 to a base 64 string. That is done so it is easier to send over the line, because then we do not have spaces and weird characters in it. Then we have the standard base 64 characters instead. So that is the encryption right here. And where do I get all of these cool classes from? I actually get them from the JavaX crypto and then Cypher. And then we can actually say that we want to get an algorithm like Aes, and if it's not part of your if it is not part of your class path, then you will actually get an error. So then you will get an exception right there. Let us just check right here. It does not throw anything, but actually it can throw an illegal argument exception. And yeah, there we set the algorithm right there, and then we have the Cypher instance, which is right here. And again, it checks whether this Cypher transformation is actually available. This is CPC, and with some padding included right there. CPC is also a very popular variant of the transformation when you're dealing with Aes256. But you have to be very specific when you talk to someone, and when you agree on a way of actually encrypting something. Because if you're just slightly off, then of course you cannot read the encrypted data at all, of course. So Here in the decryption, in the decryptor, again we're using the salt right there, and this will prepare this IV parameter specification. And then we say to the Cypher that now we're in decrypt mode, and we have to use the key. The secret key is right here, and we have to use that to decrypt the message. And again, right here we say do final, and then we decrypt the message. In this situation right here, it's actually base 64 encoded. We actually expect this to be base 64 encoded, but let us remove that. We will just say message. Let us remove the base 64 encoding part of it. It does not matter. We do not need this for this demonstration right here. And then let us go to, and we do the same thing right here. We don't need to base 64 encode the encrypted bytes in the end right here. And then we say, we return some bytes. That's fine. In a byte array, it's just an array of numbers. And those numbers then they represent. They can represent characters, for instance. They can also represent. They actually just represent numbers. It is just an array of numbers that we have right here, and then we can choose to get some kind of string representation out of that if we want to. So here we have the byte original right here. Let us just return that. So that is the. We'll just return the bytes. So decrypt, then we say byte. Do final. So what is it complaining about? It should be bytes. Okay, get bytes. I think actually get bytes. I don't think we need to say that it's UTF-8 all the time. I think actually get bytes we'll actually choose that per default now, but that's another story. So okay, so now we have decrypt that returns some bytes, and we have encrypt that also returns some bytes. Let us see if we can make a cool test that actually works with this Aes256 encryption right here. So I'll say new Aes encryption right here, and here we need to give the value and the key and the salt. So let us just create that. So we have a message. This is a secret message with secret message right here. Equal to programming is fun, and the cloud is cheap. That's not true. So, but it's awesome and scalable. So now that is a secret message that we have right there. So then we have then we can say that now we have the key equals to QWERTY 1234. This is a very strong key, of course, that no one can guess. Salt equals to pepper. So that is the salt that will actually help us make some randomization and will actually help us to do the encryption. So the salt is usually not that secret, but of course the key is very secret usually. But the salt is used for both for the encryption actually and also for the decryption. So now we say here we take the value secret message that get bytes, and again I'll try not to mention the UTF-8 encoding to begin with. We'll see if it gives us any problems. Then we'll say key dot get bytes, and we will say salt dot get bytes like this. The reason why we like bytes when we are encrypting stuff is because that is just numbers. Encryption is actually also just math, and so we actually want to be more concise with our bytes. Then we say encrypt right here, and then we also get some bytes back. So this is the encrypted value. If we want to represent this somehow as a string, that is actually instead of saying new string and then say the encrypted part right there, then that will actually not give us anything. Then you can actually, but if you convert it into hex instead, hex format, in Java we now have a hex format class. You probably did not know that. I think it was came in Java 17 or something like that. This means that you do not have to convert the numbers into hex and the other way around by hand anymore. So that is really, really cool. Format, let's just say here, where is the extra format off? Okay, and then we say format hex, and then we give it the bytes. This means that now I can get a string representation that I can print out in the log. That's the only reason why I do this. Hex encrypted. The only reason why I want to do this is because then I can kind of see for myself what is actually going on, and I can actually see the value, right? So then it's much easier to compare hex strings than this to have an array of bytes where we have to go through each byte. Is this okay? This is 4. This is 2. This is 3. This is 2. And oh, there was an error there. There was a mismatch there. And then this is much easier, of course. So that is the encrypted value. Okay, let us start with that. So first we encrypt it. So that's the first step. We encrypt our message with Aes256 encryption. And the IV length must be 16 characters. That's correct. That is because the salt needs to have, since we are using this, it needs to be 16 bytes long. So let's go back. We will say pepper 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Let us see if it's better now. Aes key length 10 bytes. That's also wrong. So we need also a good key. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let us also make that 16. So. Okay, so now we have this string right here, and this is the hex representation. So let us just take that right here. So this actually means that what this hex representation is right here is that all of these hex decimals, these hex numbers right here, these are not decimal but numbers. These are just hex numbers like this. that is what the string consists of. That means that we can actually, that just means that now we have some output that we can actually compare with something, right? So now we can actually, and the reason why we want to do this is because then we can actually take another, let's say we have another test. This is our encrypt test. First of all, we can say we can create an assertions and assert true, assert equals. And then we can say that we actually expect this message right here, and this to be equal to the hex encrypt message. So this means that now we have actually assert something in our test, and our test should always assert something, or else it's not a test, right? So, and here we have decrypt message. So now we have two different tests, one for encryption and one for decryption right here. And of course we could do that in one test, but just now for fun, we will actually say that string already encrypted equal to, and this is actually the hex value. So this is the hex value that we have right here. And of course, if we want the bytes for that, then we need to already encrypt it. Then we need to say we want the hex format, then we want the auth, then we want the parse. We want the parse hex right here. So that means that now we will actually get bytes instead. So now we have the numbers again. So now we got the numbers returned. That is why we like the bytes right here, because it's math, it's numbers. And now if we say new AES decryption like this, and here we give let us move the salt and the key up here. Actually also the message. So now it's shared between the tests. So that here we will say, put in the message. Now that is now the bytes that we just have, the bytes there. Then we have the key, and then we have the salt like this, and then we say decrypt. Thank you very much. And then we say decrypt. So now that we are decrypting it, now that means that now we have the what is the matter right here? Yes, decryption. Yeah, but I don't. This is the decrypted string. That should not be a string. That should be it should be bytes actually. So, and that's also what we are doing here actually. So I don't like it when decryption and encryption help us when they take strings. You never know what kind of string format is actually required. So here we have the byte. Okay, but in this situation it's okay. So let me say get bytes. Salt, we say get bytes. It is math, so it's we like numbers. We don't like strings because are the string in hex format or whatever? Yeah, are the base 64 encoded? We don't know it. So now we decrypt it right there. So let me say assertions that assert true, assert equals. And now we actually expect that if we take the original string, the original message, the secret message, and then we say new string on the decrypt part right here, then we want those to be the same, right? That's actually what we say. And of course, we could also do this right here. Let's see if this works. Yes, programming is fun. And the cloud is awesome and scalable. So this is encryption. This is encryption. This is AES encryption. And there are a lot of standards out there. We like standards are awesome. That's why there are so many of them. It's such a good joke. Your colleagues will never get sick and tired of that one. So just continue with that. Yeah. So this is encryption. Feel free to, as usual, to find my project on GitHub. Thank you very much for watching and have a great evening. Bye-bye.